All right, I think we can get started. So I have some problems here. So typically what I do is just kind of give you some time to solve this problem that's up here, and then I'll go over it. Um, I can make it a little bigger. This one I think was supposed to be multiple choice, but it doesn't have the answers, but we'll just kind of solve it if it's open-ended. Okay, so we could go over this one. This one is a little bit challenging. It doesn't have a lot of work to do. Um, but it's kind of hard to know, I guess, what to do. So the idea is this is all the combinations of like the M type stars and the K type stars. So just like for example, like this point here would mean you have 80 of these and 70 of these. And the M type stars each weigh a certain amount, and the K type stars weigh a certain amount. And when you add their masses of 80 of these and 70 of these, it's going to be this number. So the point that I highlighted is not very helpful in that I just want to explain like what the problem is saying. And a lot of times they give problems like this, and our focus really needs to be on the intercepts. So the fact that we want to know what is the closest to the mass of each M type star, all we this is the combination we care about because they don't mention anything about the K. So we actually want the K to be zero. So if we think about what this point means, 160 comma zero, it means if we were to only have 160 of these M type stars, let's say each M type star weighs M, and none of these, then this would be the weight of all 160. So essentially, we're just like solving this. All right. So if we pick any other point along here, we can't solve it because we don't know what K weighs and we have too many variables. So that's why this entire diagram, the only thing we really care about is this point. And if we do solve this, we get around 799.3. Again, I think this problem was supposed to have multiple choice, but the way it was screenshotted, it wasn't there. Um, so the actual problem would have been whatever answer was closest to this. So 799, 800, somewhere around there. All right. So I've seen problems like this before, and the focus is to just pay attention to the intercepts. So this intercept is when you have 160 of one type and none of the other. This intercept would have been 140 of the type K and none of the other, but that didn't really apply to this problem. Okay. Let's take a look at number two. Like this. So we can see the timer. I usually give about a little more than a minute and a half. This is another one that I think the screenshot when it was sent to me is like missing the multiple choice. But I think it's like every combination of like one and two, or one and not two, or two and not one, and neither. But again, we'll just talk about each one. Okay, so let's kind of talk about we definitely don't want to calculate really any of this. We want to just have an idea of what effects certain numbers have on medians and means. So the first thing to notice is that if we add a person who's scoring 18 points, that's going to be like somewhere here. So that is going to be like a low outlier. And what that is definitely going to do at all times is it's going to pull the mean closer to it. So if you add a number that is smaller than the mean, it'll lower the mean. And if you add a number larger than the mean, it'll move the mean up. The only way the mean ever stays the same is if you add the number that is the mean. Like if your average in a class is a 91 and you get a 91 on a test, then your average is going to stay the same. So that tells me that number two, um, the mean for data set B is less than data set A. That tells me that that is true. So I started with that one because the mean is the easiest one. Now for median. The thing is, we don't have enough information to know exactly what would happen with the median for two reasons. First of all, well, I guess the main reason is we just don't know all the data points. This is a histogram. So the median is somewhere between 50 and 60, but we don't know what number. So if we add a lower value, it's possible that the mean will shift down. Sorry, I keep saying mean. The median will shift down by one, or it could not change at all. So the fact that we don't know what would happen to the median tells us the key word here is must be true. So one doesn't have to be true. It's quite possible, but it doesn't have to be true. So again, I think whoever sent this was missing, I think, the answers. The answer would have been two only. So the median is usually not affected by low outliers or high outliers, but it could still change slightly. And we don't know whether it will or not. But the mean is always affected by low and high outliers. It moves towards whatever one it is. All right. If we have no questions, let's keep going. All right. Number 3, I'll start the timer. This is a geometry problem. Here we do have the answer choices over here, and I covered up the actual answer. So, okay. All right. So this one is a pretty challenging, I think, geometry problem. So we got two lines that intersect at one point. And the measure of one of the angles is 9x minus 140. Well, hopefully we know that means that this angle over here is also 9x minus 140 because they are vertical angles. And then the other two angles, they're congruent to each other as well because they're vertical angles. The way we would find that angle is it's supplementary with either one of these. Now we have to be careful. We need an expression for that angle. So just think about what you would do if you knew what the value was. Like if we knew this was 60 degrees, the other would be 120 because we would do 180 minus it. So we got to do 180 minus this angle. Now, be careful. You got to use parentheses, or at least then distribute the negative. So you get 180 minus 9x plus 140, and then 180 plus 140 is 320. So the other angle is 320 minus 9x. And then the question says, which could not be the sum of the measures of any two angles? Well, if I add the two consecutive angles, they're supplementary, so we definitely can get 180. So that's just wrong. That would just always be wrong. Then if we add the two angles going this way, that'll give me 18x minus 280. So C is wrong because again, it's which one could we not get? And then I'll add the angles going across this way, and that is 640 minus 18x. So I could get negative 18x plus 640, so B is wrong. So the answer must be A, because I added all the possibilities and never got negative 18x plus 280. Okay, questions on that one?
I have a question.
Yeah.
Why? I'm sorry, a little confused on why B isn't the answer.
Um. Okay. Let me go back. Okay. Did you see where I got like all these expressions from?
Yeah,
Okay.
I understand the congruent and the how what the angle is supplementary to the 320 minus 9x,
Uh-huh.
but I thought B was the answer. So I don't know. I'm a little confused on why B isn't. I
Okay.
know I see B on here.
Yeah, so it just says which could not be the sum, so of the measures of any two of these angles. So I just started adding them together. So if you add the 9x minus 140 and the 9x minus 140, that gives you 18x minus 280. So since I got that as a sum, that's why I eliminated C. D is if you add the 9x minus 140 plus the 320 minus 9x, that'll give you 180. And then if you add the 320 minus 9x and the 320 minus 9x, that gives you 640 minus 18x, which is the same as negative 18x plus 640. So since I can get that sum, that can't be the answer because it says which could not be the sum.
Okay, thank you. I think I misread the question. Thank you.
Okay, yeah. Yeah, these ones are tricky when they say could not be. Okay. All right, let's take a look at number 4. Okay, this is a pretty challenging problem. So if we have a rectangular prism, try to draw one here. Whoops, it's pretty bad. Okay, so they tell us that the area of the base is 24t. I'll get to that in a second. The length of the base is 8/3, and the height is 15. What expression represents the surface area? So what we really would like is the width. Well, we know the area of the base is a rectangle. So that 24t represents the length times the width. So 8/3 times W. So W is the width. And I'm just going to solve that for W. So if I multiply each side by 3/8, 3/8 of 24, use a calculator if you need, is 9. So that means the width is 9t. All right, so that's the first thing we probably should do in this problem is use the area of the base to be able to find the width because we're going to need the surface area. So then when we think about the surface area of a rectangular prism, it's just the sum of all the rectangles that make it up. And there's 6 of them total, but they come in pairs of 2. So if I look at the bottom and the top, well, I already know that the area of that's 24t. So both of those together is going to be 48t. Then if I look at the sides are 9t by 15. So if I multiply those together, that gives me 135t, but there's 2 of them. So if I multiply that by 2, I get 270t. All right, so far I did the top and bottom are each 24t. The sides are each 135t. And then I won't color this in because it'll be difficult. But now my front and back are 8/3 by 15. Well, if you do 8/3 by 15, you get 40. And then you double that and you get 80. Okay, so again, the 48t is the bottom and the top, the 270t is the sides, and then the front and back is a total of 80. So if you just add these together, you should get 318t plus 80, which is answer choice B. All right, if we are good with that, then let's keep going and let's take a look at our 5th problem. So I just want to start the timer. I can make this one a little bit bigger. All right, so the way I like to do these is just set up equations. So we think of the word is as equals. So my first equation is sample A, so I'll just call that A, equals 460% of sample B. So 468%, the way we go from percentage to decimal form is we divide by 100. So that should be 4.68B. So that's what this first equation is. Then the weight of sample, oh, and the weight of sample A is now 0.78%. Now we got to be careful with this. When we go from percentages to decimal form, even though this has a decimal in it, it's still in percentage form. You have to divide by 100. So that is 0.0078 C. So these are the two equations that first sentence gives me. And then if the weight of C is, so what I want to end up doing, what this tells me here, is I want an equation that has C in terms of B. So the first thing I'm going to do is just set these equal to each other to get rid of A. So that means 0.0078C is equal to 4.68B. And then if I want C is, that means I want C by itself. So I'm going to divide each side by the 0.0078. So C is, and if I do 4.68 divided by 0.0078, I get 600. This is where we have to be careful because I would guess that a common wrong answer here would be 600 because it says C is a certain percentage of B. Now we got to remember with the numbers that we put in front here, those were in decimal form, which means they were from percentage divided by 100 to get to them. Now we have this. This is actually in decimal form. So to figure out the percentage, we have to multiply that by 100. So we actually get 60,000%. So C is 60,000% of B, which seems kind of ridiculous, but it's the answer. So that's why it's a hard problem because it's so strange. Like you wouldn't expect an answer that large. But you have up to 5 characters, so it kind of makes sense. So the answer, even though it's 60,000%, what they want is the value of P. So the answer you would put is 60,000.
Just to be clear, it became the 60,000 because of the decimal.
Yeah, so basically when you have percent form and you're going to decimal form. So decimal form doesn't mean necessarily that it has a decimal in it. It just means it's what you would use in an equation. So like a quick example would be if something was 25%, in an equation you would use 0.25. And the way you go from percent to decimal is you divide by 100. And then the way you go from decimal to percent is you multiply by 100. So since I got this 600 as part of this equation, that C is 600 times B, that 600 is technically this type of number. It's in decimal form because it's part of an equation. And to convert it to percent form, I have to multiply it by 100. So it's actually 600 times something is really 60,000%.
Got it. Thank you.
Yep, you're welcome. Okay, so let's keep going. This one's pretty tricky. I mean, all we have to do is figure out which one of these systems represents it. And honestly, every one of them is the same here. So we don't even have to worry about that part. So the entire problem is just figuring out which one of these makes the most sense. And this is just has a common error that people make. So we want to have at least 3 times as many tulips as roses. So I feel like a lot of students pick the one that has like the 3T in it. But the actual answer, let me think about this. Yeah, I'll just tell you the answer first. The actual answer is C. And it seems kind of counterintuitive because it says 3 times as many tulips as roses, but it's the roses that are actually being multiplied by 3. Um, because the first thing I'm going to do is imagine that it were to try to explain this is to imagine it were an equation first. So just forget about the at least for a second. And let's just say I have to have 3 times as many tulips as roses. That equation would actually be T equals 3R. Because if I have to have 3 times as many tulips as roses, it's the roses that needs to get multiplied by 3 so that it's equal to the tulips. And again, you can think of an example. If I told you you had to have 3 times as many tulips as roses, something that would work is if I had 5 roses, then I would need to have 15 tulips to have 3 times as many roses, or sorry, 3 times as many tulips as roses. So I think we can all see that this would work, and then this would now satisfy this. So you can see the roses is what gets multiplied by 3 to get the number of tulips. Then if I need this to be more than multiplying this by 3, that's where the t has to be greater than or equal to get me the at least part. And if that still doesn't make sense, then just pick an example that you know will work. So and that might not get the final answer, but that'll at least eliminate some of them. So like again, an example that would work might be 5 roses and 17 tulips, right? That's more than 3 times as many. And if you kind of use this, then A goes away because 17 is not less than or equal to 15. This is where, and then here, 3 times 17 is not less than or equal to 5. Obviously, this one works because it's the right answer. Here's where we get into trouble, though, because 3 times 17 is more than 5. So, like, picking numbers doesn't narrow it down to just one. So, picking numbers here is not helpful to get the final answer. You really have to kind of understand how to come up with this yourself. All right, let's take a look at number 7. Okay. This is one that I am going to do strictly in Desmos, because think I think that's probably the fastest way. So rather than even trying to write this equation, I'm going to show you how I would do this in Desmos. So let me just hop over there. So anytime they give you 2 points and giving you input and output of functions 2 different ways, the way they did is 2 points. You can use a table in Desmos. So you just go to the table. I'm going to put 2 and then 13.5. That's the f of 2 is 13.5. And then I'm going to do 14 and 22.5. And then you hit this little button on the side, add regression, and it gives me the equation. But I'm not really too concerned about that equation. I'm more concerned with the graph. So then what I know is if we want to do this whole thing in Desmos, is I want my output to be 18.75. So I'm going to graph y equals 18.75. And then look at the intersection with the line that came from the table of information that we put in. So that tells me that the input to that function must be 9. That's what would give me an output of 18.75. But that's not the answer because the problem, so let's just remember that. So an input of 9 is what gave us 18.75. And then when I hop back to the problem, what we just figured out from Desmos was that f of 9 was 18.75 based off of this information, which just tells me that x itself must be 8. Because 8 plus 1 is 9. So you can certainly do that by hand, but I really like the Desmos table for problems that just give you points and then you have to come up with the equation. I think it's faster. All right, let's keep going. All right, got another, I think, pretty challenging problem. I'm going to do this, I guess, the more straightforward way. One way to do this, it may or may not be faster than what I'm about to show you, but one way to do this would be to just pick your own values for A and B, go to Desmos, or actually, you're going to need the equation anyway, so I'll show you how to get the equation. And then maybe graph it in Desmos, find the y coordinate of the vertex, but then you got to plug your values of A and B into each answer to see which one matches your vertex. So I think that's a legitimate way to do it, but I am going to go over, I guess, the more like straightforward way, or the more, I guess, mathematical way. So one thing to notice is that if the leading coefficient is 1, the equation should be x minus a and x minus b. And that's just by the nature of, we have to understand that these are x-intercepts, right? They tell us they intersect the x-axis, and intercepts have this relationship to factors. So if a is an x-intercept, then x minus a is a factor. And if b is an x-intercept, then x minus b is a factor. So that is the first part of this. Now, another important concept is this is an intercept form. When you're in intercept form, the x coordinate of the vertex is always the average of the x-intercepts. And that's because a parabola is symmetrical. And if it has, wherever its x-intercepts are, the vertex is going to be in the middle, which is the average. So that's a plus b over 2. Okay, so just to kind of recap the important concepts here. If you have an x-intercept, x minus that intercept is a factor. When something's in intercept form, the average of the x-intercepts is the x coordinate of the vertex. Well, unfortunately, we want the y coordinate of the vertex. So we've got to plug that in for x and then solve for y, and then that'll give us our answer. So what I have is a plus b over 2 minus a, and then a plus b over 2 minus b. Now, it just depends on how quickly you can do your algebra. If I want to subtract these fractions, then I want this to be 2a over 2, and then I want this to be, 2b over 2, just to get a common denominator. And I am going to try and skip some steps here because, again, this is just a long problem. So if we can remember subtracting fractions, we have common denominator. This is a plus b minus 2a. Well, that's b minus a. And this is a plus b minus 2b. Well, that's a minus b. And then I'll go up here. Well, this is b minus a and this is a minus b. They're pretty similar to each other. If I factor a negative out of this, then I'll get negative a minus b over 2. And then this one is a minus b over 2. And that's where I'm going to stop, because a minus b times a minus b is a minus b squared. And I have a negative, and these 2's on the bottom make 4. So that should give me answer choice B. Okay. I do want to do it the other way because I'm just curious myself. So what I'm going to do it the other way is I'm going to just choose. Here, I'll do a different color. I'm just going to make like A 2 and B 4. So I'm going to do x minus 2 and x minus 4. So remember that, x minus 2, x minus 4. And then I'm just going to jump over to Desmos. And I'm going to graph x minus 2, x minus 4. And I'm going to find the vertex. And the vertex is negative 1, the y coordinate of the vertex. So now I'm going to remember that. So I get here pretty quickly. So this method is probably going to be better. So y coordinate of the vertex is negative 1. So let's remember that. And we'll hop back over here. And I want the y coordinate of my vertex to be negative 1. So I want the answer to be negative 1. but I want to remember that I chose A to be 2 and B to be 4. And you can see this one, 4 minus 2 is 2, 2 squared is 4, and 4 divided, 4 times negative 1/4 is negative 1. This one actually gives me positive 1. And then these ones we could do, but I think you'll quickly see when you try them, you don't get negative 1. So I think in the end, choosing your own values and using Desmos is going to be quicker. But these concepts are extremely important as well. So knowing how to get this form, we needed to know regardless. And then knowing that the average of the x-intercepts gives you the x coordinate of the vertex. So all important concepts, just I think this one, the quickest way to do it would be just pick values, use Desmos, and then plug them in. Okay, if we're good with that, let's see. Let's take a look at number 9. Okay, this one's a tough problem, but it doesn't have a lot to do. So this is your typical SAT problem, like hard SAT problem, where there's not like a lot of work. It's just you got to like just know what to do. So the first thing we have to understand in these is this 155, whoops, represents the initial amount. You don't need that for this problem, but it's helpful. I like to review like all the concepts. So this should be our initial value anytime we have an exponential model. And it says, how long does it take for it to increase by 14%? So separately, we should know that if we want to increase something by 14%, that's the same as multiplying it by 1.14. So that's just a way to increase it by 14% in one step. So what we're going to do is whenever we multiply 155 by 1.14, that is going to increase our original revenue by 14%. So what I really want is an exponent of 1 up here so that I actually do get 155 times 1.14. And hopefully we can see that if I just make t 3/4, because anything times its reciprocal is going to give me the 1. If I make t 3/4, then 3/4 times 4/3 is 1, and I will be doing this. I will be doing 155 times 1.14, which will give me the 14% increase. So seemingly the answer is 3/4, but we do have to be careful because that's in years and they want months. So we do 3/4 times 12, which is 9. So 3/4 of a year is really just 9 months. So in 9 months, we will be increasing by 14%. Any questions on that?
I have a question.
Yeah, go ahead.
So I don't I don't really get what the 155 and the 1.14. I think that looks like the 14%. But I'm not sure how to like way that you kind of explained it, if that makes sense.
Yeah, so like imagine we just like started with like another number. Let's say we started with $200 and I wanted to increase that by 18%. The way that I would increase that by 18% is I would just multiply by 1.18. So this is like a percentage understanding that we have to have that doesn't have anything to do with this model necessarily. Because one way to find this would be to multiply by 0.18 and then add it back to itself, but that's 2 steps. So the way to do it in 1 step is just to multiply it by this. So does it make sense that if you multiply by this, that's an 18% increase? So therefore, multiplying by 1.14 is a 14% increase. Does that part make sense?
Yeah, and then
Okay.
when you have the exponent to the one, then you're basically just you're doing it.
Yes. So the
Yeah.
question really is, what value of t is going to give me an exponent of 1, and that's 3/4. And 3/4 is in years, and 3/4 of a year is 9 months. So does that make sense?
Yeah, I thought they were asking for T, but they were asking for like months in terms of T, kind of. So yeah, thank you,
Yeah.
thank you.
Okay, good. Nice. Yeah. That's again, I'm sure a common wrong answer on this problem would be 3/4. Um, Okay, so yeah, always pay attention to units. All right, I think we have time for one more prop. We'll do this last one. Okay, I don't know why this one doesn't have a timer. I'll just give you like a minute and then we'll go over it. All right, let's go over this one. Okay, there's a bunch of ways that we could kind of map this out. I'm going to just kind of go over it this way. So I'm going to start with cylinder A. And I'm just going to figure out everything I can about cylinder A because they give me the radius. So I start with the volume. We need to know, well, so we don't need to know this. We need to know that this is on the reference sheet. The volume of a cylinder, which again they give you, is pi r squared h. So I know that the radius is 2. So this right here is going to help me find the height of cylinder A. So again, pi r squared h, r is 2. The volume is given as 100 pi. So divide the pi's out, and 100 divided by 4 is 25. So 25 is h. Now I'm going to go to the surface area. Just call that S. They give me the formula here. That's 2 pi times 2, radius of 2, and then radius plus height 2 plus 25. So this is 27 times 4. So this gives me 108 pi. So what I just figured out was that the surface area of the cylinder A is 108 pi. Then what I'm going to use is this idea of scale factors. So scale factor is just what like each dimension is multiplied by from the one cylinder to the other, or just in general one figure to the other. Right now, I know the volume is being multiplied by 8. Whatever happens to the volume, that is the scale factor cubed. So again, the volume got multiplied by 8, which means the scale factor cubed is 8, which tells me K is 2. So that's the scale factor. But what I want to know is what happened to the area. And area is the scale factor squared. So that's, whoops, now that came back. So now it's 4. Whoops. So that means that the area of the first cylinder is going to get multiplied by 4. And if you multiply 108 pi by 4, you get 432 pi. Now, another thing that you could have done if that was confusing was you needed to figure out that the scale factor was 2. And then you could have multiplied the height by 2 and the radius by 2 and just found the surface area that way. But either way, the answer is 432 pi. So any questions about that one?
I have a question.
Yeah, go ahead.
If we see a problem like this, like, should we just like skip it? Because I never learned anything about scale factor.
Um, Definitely not. Scale factor is like an important part of certain like area volume problems. So I can definitely make sure next week to like include more scale factor problems just to kind of go over that because the SAT likes those types of problems because there's like a long way to do it and the scale factor typically is like a shortcut. This problem was kind of ridiculous, I agree, but I can next week I can make that kind of like a focus to go over like scale factor problems to kind of help understand that more.
I have a question.
Yeah,
Could you explain why you did K cubed?
because whatever because the volume is three-dimensional, so whatever happens to the volume, that represents the scale factor being cubed.
Okay, makes sense. Thank you.
Okay. And again, I'll make sure that next week I'll do like ones that are a little easier than this. We'll like build. I can like kind of focus on like the idea of scale factor. So I do think it's like an important problem. Okay. All right, then that is our time. So thanks for coming. Look out. I'll send an email with the YouTube link to this and the answer key, and then I'll request people to submit problems. I'll send that email out later in the week. So thanks for coming, and hopefully I'll see you again next Monday.